Okay, so here we are in chapter 3 with body defense mechanisms. Be looking at the three lines of defense in the body systems and how it distinguishes self from non-self. We'll look at antibody mediated responses and cell-mediated responses, steps of adaptive immunity, and then active and passive immunity, as well as some antibodies and problems with your immune system. The body generally defends you against anything that it does not recognize as being part of you. Common targets of the defense system include pathogens, which are disease causing bacteria, viruses, and so on, and also cancer cells, which are once normal body cells whose genetic changes cause unregulated cell division where they can't stop growing. You have three strategies for defending against foreign organisms. You have physical and chemical surface barriers. They're nonspecific, they keep foreign organisms or molecules out. And then you have internal cellular and chemical defenses, which are also nonspecific, and they'll attack anything foreign that has gotten past the surface barrier. And then you have an immune response, which is very specific depending on what has invaded you. You have specific type of cells that will attack that substance or structure, and it will destroy specific targets and also remember them. So this is the first line of defense. If pathogens penetrate barriers, the second line of defense will try to take it out. And then if a pathogen survives non-specific internal defenses, the immune response is initiated. So your physical barriers are skin and mucous membranes, and I'll let you read through those. Chemical barriers and the lining of the stomach. Some of your chemical barriers include urine and saliva and tears. And here's some of this just first layer of defense. Your skin, your tears, your large intestine, and I'll let you guys read through this. And again, feel free to pause the video at any time. Your second line of defense includes phagocytes, which are a type of white blood cell that engulf pathogens, neutrophils, macrophages, and eosinophils, all types of white blood cells that will have a role. And then you have natural killer cells, which will search out abnormal cells like cancer and kill them. So this is a look at a cell getting ready to engulf this little piece of bacteria right here. Another cell engulfing something foreign. Again, it's pretty interesting to see how your body defends itself. Interferons slow viral protection. So small proteins secreted by a cell infected by a virus, they will attract macrophages and natural killer cells that will destroy infected cells, and they'll stimulate neighboring cells to make proteins that prevent the viruses from replicating. The complement system assists other defense mechanisms. This can be a group of proteins that enhances other defense mechanisms, and it will destroy pathogens, help phagocytosis, which is the eating or engulfing of something foreign, and stimulate inflammation. So here's an activated complement protein forming holes in the cell wall of the bacteria so that the bacteria can no longer maintain a constant internal environment. Water will enter the cell and eventually burst. The second line of defense we say is inflammation, which will destroy invaders and help repair and restore damaged tissue. There's 4 signs of inflammation: redness, heat, swelling, and pain. And we're all used to these if we've ever been hurt or stung by a bee or gotten something into our skin. Redness is caused when mast cells release histamine, which causes your blood vessels to dilate, delivering defensive cells and removing dead cells and toxins. Heat temperature rises as a result of increased blood flow, and this helps to speed healing and activities of defensive cells. Swelling, histamine also causes your capillaries to become leaky, so fluid will seep into the tissues and bring clotting factors, oxygen, and nutrients. And pain can be caused by excessive fluids, bacterial toxins, or prostaglandins. This is a great video that I'll let you guys watch on your own. And this is just show what happens if you get some sort of foreign object into your skin, how your blood vessels will widen, the capillaries will become more permeable, and then how complement destroys the bacteria and phagocytes, and then a clot form. Fever is also part of the second line of defense. It's called by pyrogens, which are chemicals that reset your brain's thermostat to a higher temperature. Usually a mild or moderate fever helps fight bacterial infection because high temperatures will do that. But a very high fever, anything over 105, is considered extremely dangerous. And the third line of defense, again, this is where we get into specific responses. We have what we call adaptive immune response, where it has specific responses and memory, where organs of the lymphatic system are involved in this, and it's defined by its function. So it'll help recognize and destroy specific pathogens on foreign molecules. It's very specific, it's directed at a specific pathogen, and it will remember that pathogen and attack it so quickly that illness would never result upon a second exposure. MHC stands for Major Histocompatibility Complex Markers, and these are molecules found on our own cells that label the cells as self, and this is used by your immune system to distinguish cells of your body from foreign invaders. Antigens are non-self substance or organism that triggers an immune response. They're usually large molecules such as proteins, and they're often found on the surface of an invader. So this is a self marker, and then an antigen is something that the immune system would recognize as a foe. Lymphocytes are a type of white blood cell. They're responsible for specificity and memory. B lymphocytes form and mature in bone marrow, and T lymphocytes form in the bone marrow and mature in your thymus. And the T lymphocytes, or your T cells, are what recognize those self markers. Specificity to recognize one type of antigen results from each cell developing its own particular receptors on its surface. And when an antigen fits into those receptors, then the body will target that antigen. They'll divide repeatedly, forming either effector cells, which are short-lived cells that will attack the invader, or memory cells. Antibody-mediated immune responses versus cell-mediated immune responses. If it's an antibody-mediated immune response, then it'll defend against antigens that are free, and it'll have effector B cells that use antibodies to neutralize an antigen, and we can see that in our blood typing. And cell-mediated immune responses protect against cancer cells and body cells that have become infected. Specifically, cytotoxic T cells will cause cancer cells and infected body cells to burst. So here's a great graph looking at the type of cell and the functions. And then the steps in the adaptive immune response. Another great graph to show when the threat is identified, how cells come through and either get rid of it through the antibody-mediated response or cell-mediated response. So the steps of the adaptive immunity, which that graph just kind of showed, these take you through the steps here that I'll let you read through on your own. The threat, detection, and then alerting. The last step would be cause for alarm, where helper T cells will activate other cells to destroy the specific antigen. These cells will divide to form clones of cells designed to eliminate that specific antigen from the body. Clonal selection is critical to the adaptive immune response. Building defenses then, after that something foreign has been attacked, B cells from your plasma cells that secrete antibodies will bind to antigens. T cells form cytotoxic T cells that attack, and the process by which they increase in number is termed that clonal selection, which we just went over. Then the defense is the antibody-mediated response. Antibodies are secreted by plasma cells. They're specific to an antigen, and then they'll eliminate that antigen. An effector cytotoxic T cell releases perforins, which cause holes to form in cells with that particular antigen. So here's the threat, detection, alert, alarm, building specific defenses, defensed, and then continuous surveillance due to the antibodies that are now circulating in the plasma. They will hold on or be involved with the memory B cells, which will be able to then remember anything that's foreign. This is just showing how the antibody is this Y-shaped structure, and the heads of it are designed specifically to attack or attach onto specific antigens of something foreign, either a bacterial cell or a virus particle. So it's able to bind and then be able to get rid of that either foreign bacterial cell, if it's this antibody, because these will fit onto their antigens, or this foreign virus particle, because these antibodies heads will be able to fit directly on those surface antigens. Immunoglobulins are 5 classes of antibodies, each with a specific role, and they're listed here. It gives you the structure, the location, characteristics, and protective function. So I'll let you guys work through those, but these are just different classes of antibodies. Again, they'll all have a Y-shaped structure. And this is showing how the antigen and antibody will react. Continued surveillance. Memory allows for a more rapid response on subsequent exposure to a foreign antigen. The primary response occurs during the body's first encounter, and the antibody concentration will rise slowly. And the secondary response occurs during subsequent encounters with that antigen. It's a strong and swift due to the large number of memory cells programmed now to respond to that particular antigen. So this is just a look at a graph showing the time in days of the first exposure, the primary response, and the immune response on the y-axis. You can show how the immune response for the first exposure is pretty low, but the second response is much higher because now the body has those memory cells which know how to react. Withdrawal of forces, suppressor T cells will turn off the immune response when the antigen no longer poses a threat. So that's kind of the last step there. And this is a great look at all of the steps in the adaptive immune response. I know it's kind of complex and involved, but they all kind of go in order and hopefully make sense. Active immunity is when your body produces those memory B cells and T cells following exposure. It will occur naturally when a person gets an infection. So let's say you got chickenpox when you were 5. All of you are probably way too young, so you all got vaccinated for that, but I got chickenpox when I was like 5. So that happens naturally. So my body has those antibodies built up against chickenpox, and I'll never get chickenpox again. But active immunity can also occur through a vaccination where they will introduce a harmless form of an antigen into the body to stimulate an immune response. So that's very beneficial. It's very long-lived because memory cells will be produced. Passive immunity results when a person receives antibodies that were produced by another person or animal. So this happens a lot through babies drinking breast milk or through the placenta. It's short-lived because the recipient's body was not stimulated to produce memory cells, so you want that active immunity more, so babies still need to get their vaccinations. Monoclonal antibodies, it's a group of identical antibodies that bind to one specific antigen. These are used in research, clinical diagnosis, and disease treatment. This is an example of this is what's used in a home pregnancy test. Some autoimmune disorders, we'll end with this. They occur when your immune system fails to distinguish between self and non-self and attacks tissues or organs of the body. So if you ever hear of something, it's an autoimmune disorder. One example is rheumatoid arthritis, where your body continues to attack itself because it can't recognize what is self and what is non-self. It can be organ specific, and that's usually caused by problematic T cells. Hashimoto's thyroiditis is an inflammation of your thyroid, or type 1 diabetes, where the cells in the pancreas are unable to produce sufficient insulin. It can be non-organ specific, where it's usually caused by problematic B cells. An example of this is lupus. Then where do allergies fall in? So allergies are an overreaction by the immune system to something foreign, a foreign antigen. The antigen is usually harmless and it's called an allergen. An example is hay fever. That's why if you guys are listening to my lectures, I always record them at about 5:30, 6 in the morning, and I wake up with allergies, so that's why I sound really congested. Pollen grains, dust mite, also calling allergies. My home isn't dusty. I think my allergies are caused by pollen. or something crazy in the air right now. So steps in allergic reaction: during the first exposure, allergens will cause plasma cells to release the IgE antibodies, which will bind to mast cells or basal cells. And then on subsequent exposures, the allergen combines with those immunoglobulins attached to the mast cells and cause the release of histamine. And that's what causes redness, swelling, itching, other symptoms, congestion, runny nose. So this is the look at an allergy response. Anaphylactic shock is another problem of the immune system. It's an extreme allergic reaction that can be fatal. It can cause pooling of blood in capillaries, which will make breathing difficult. Common triggers can be insect stings, if you're allergic to insects, some sort of medications, penicillin. Some people are allergic to sulfur medications, or even such foods like shellfish, and peanuts is the big one with kids right now. Allergens can be identified by injecting a small amount of suspected antigens and then monitoring the skin response. And this is how parents will test their kids for allergies. Treatments: antihistamines will block the effects of histamine. Epinephrine will constrict your blood vessels and prevent blood pressure from dropping. Or you can get allergy shots, which will inject increasing amounts of a known allergy in an effort to eventually desensitize the person. Okay, so after this, here's what you should be able to do. Again, use this as your checklist to monitor your learning. And I hope you guys are doing well. Thanks for listening.